Welcome to the webinar. Today we're here to present the true impact of SOLIDWORKS Simulation and take a critical look at how your FEA can affect your business. This is going to be an introduction to these topics if you're considering SOLIDWORKS Simulation as part of your business or you already have the tools and want to learn how to better utilize what you already own. I'm going to give a short intro for myself. My name is Robbie Hoyler, and I'm the Technical Solutions Manager for TPM's Manufacturing Division. I've been using SOLIDWORKS for a number of years, since about 2007. And since then, I've gained many certifications, including the CSWE, Certified SOLIDWORKS Expert, and the Elite AE specification from SOLIDWORKS. My specialization, among many other responsibilities, is in FEA simulation and computational fluid dynamics, or CFD. On the side, I work with a local nonprofit as Director of Operations for the Queen City Robotics Alliance here in Charlotte, where I teach high school students how to build 150-pound robots that play sports as part of a greater STEM initiative. We also use these tools in robotics to predict failure competitively. A couple of housekeeping items. You guys will see a webinar interface on the screen as you guys are participating in the webinar. You guys can type in questions at any time using the question box, and you can move and collapse any of those windows that you guys see on the screen with the X and the box with the little expansion part on there. I am going to answer all of the questions at the end, so stick around right after that for the Q&A portion. So again, you can type in questions at any time, and I'll answer those at the end. So today, we start with a question. What is the true impact of SOLIDWORKS simulation? My response: what if I could see into the future and prevent a costly design decision or mistake somewhere in the design process? Would I take actions based on that insight? Of course I would, and many of you probably would too. So what if you had a tool that can effectively do that? For our agenda today, I'd like to discuss 3 key points along those lines. What is the business case for simulation? The so what? What exactly is FEA? How does it work? And how do you use it? How does it actually make an impact on your business? How does this tool save you money, save you time? So, first topic, what is the business case? The traditional development process is a sequential process. From the preliminary concept design of the product up to the manufacturing process, product development engineers take their job step by step. Product design, product testing and simulation, design review, which may be followed by additional testing, product communication deliverables, product manuals, one after another. Often, steps are not initiated before the previous one is done. Moreover, if one of these steps, for example, if a design review identifies design flaws, it's now longer than planned, the entire cycle is longer, and then the time to market increases. This affects the productivity of the company and the ability to successfully deliver the product on time and on budget. And it is a fact that 80% of the product cost comes from the design phase. That means that it is worth spending time and analysis to understand how this process could be optimized. Now, for my next question, where does innovation occur in this process? Let's talk about that. We like to talk about innovation. We have a desire to innovate. And some companies say, we need to innovate. That's a given. But we also have no time during the project to explore new ways or approaches, right? We're too busy in our day-to-day. Our business is doing well. We're very busy, especially in this day and age where manufacturing is booming. And if we do have time during the project, we may not have the right information on time for that project to decide which is the proper way to follow. So it's complex to evaluate the risk of those decisions. So companies, in short, wish to innovate in their industries to win new customers, stay as leaders, or bring a new technology to the market. What they emphasize is that they do not have the proper tool to get technical insight on the behavior of their new products and then be able to balance the risk versus the benefits. As a result, lots of them continue to do the same thing. They'll design the same product. They may add small changes, but they're not positioning those products the way they would like, and they may not be growing that product. The goal then is to use tools during the design process to test those ideas. Companies need to be able to do the steps of product development process in parallel instead of sequentially. So here's the proposal. We can change this process up by creating that parallel process, and we can help you get information to make better business decisions earlier in the process because they can invest the needed time to do the job, and they have the right tools to have information to take action, to make decisions. Design simulation is used as a concurrent engineering tool during the design process. The objective is to simulate the product behavior while you are testing it early. So what is FEA? Virtual simulation, FEA, or CFD has existed for decades, but the unique value of the SOLIDWORKS simulation solution is its philosophy towards concurrent engineering that we just talked about, and the use of simulation by product engineers. This means that the entire solution has been developed with product engineers in mind, so they can, in any industry, benefit from a powerful, robust, but intuitive engineering tool. In short, SOLIDWORKS Simulation is a 3D tool suite designed specifically to test product designs to improve quality and safety. If your company is tasked with designing, prototyping, fabricating, validating, or approving products that you sell, then you're in the right place today to talk about the impact this tool can have on your business. And you do not need to be a simulation expert or analyst to use this product. The true impact of SOLIDWORKS simulation is only something you can answer via understanding what it is, what it does, and how you can use this insightful tool to make an impact on your business. These are examples of the many types of product behaviors we can simulate. And this does not even include our numerous other simulation packages for CFD and plastic mold design. We have those capabilities too. Most of you probably already own some simulation tool or another. What isn't displayed on this slide up here at the top left, that static for assemblies, guess what? If you have SOLIDWORKS Premium, you actually already have an FEA tool. If you want entry to get into simulation as quickly as possible, the simulation standard seat is one of the more common seats that people that will actually use. Now, we have a whole plethora of other things that we can simulate in other packages, but 80% of our customers only need this first box right here, standard validation tools for static assemblies. Let's break this down a little bit more. These tools are fully embedded within SOLIDWORKS. We always start with a SOLIDWORKS model to predict the performance of the design by adding material, fixtures, loads, and boundary information that emulates a real-life environment for the assembly. In short, this is a really powerful tool because you do not have to import or export this model into another software. That is one of the weaknesses of many of the other programs that are on the market. You have to import and export models. You have to push and you have to pull. With SOLIDWORKS simulation, we can allow for real-time what-if scenarios to be run concurrently as you design any of your products. This is how you fuel innovation, design optimization, and reduce the costs of real prototyping. I'm going to take a moment and I'm actually going to jump into the tool so you guys can see some of the tool itself and get an idea for what it would be like day to day to use this. I'm going to take a classic engineering example that we see. If you've ever taken statics or machine design, you've probably seen what's called a stress concentration before. Let's take a plate, weld one side of it to a wall, and pull on that plate, and let's analyze the stress it would take to make this part fail. In my analysis, the steps are pretty simple. I am already inside of SOLIDWORKS Simulation. I went from my model tab into simulation. It's a simple add-in. It adds a bar up here and you can begin a new study. I usually work top to bottom when I get my information. What do you need to run a simulation? You need a material. SOLIDWORKS actually has a pretty big library of materials already built in. So anything that you have from the Machinery's Handbook, 23rd edition, is in this software, and there is several libraries full of items, and you also have the ability to create custom materials and create your own specs. For anything that's not here, you can get stuff off of matweb.com, or you can access this web portal where it connects to 4 or 5 different materials labs, and you can import different geometry and material information from those test specimens into SOLIDWORKS so that you can run your own tests here locally. So you need material information. Then we have the ability to add connectors, right? Bolts, springs, washers. Then we have fixtures. So fixtures emulate how this object is supported or held up in real life. In this case, I've fixed one side of the plate to emulate it being stuck to the wall with a weld. Then I have a tensile force. So we can apply different forces like torques, pressures, gravity, centrifugal forces, bearing loads, temperatures. Or if we don't know what the force is, let's say the part moves 5 inches. We can put a prescribed displacement of 5 inches there, move the part, and let's see what kind of damage occurs if we do that to the part. So after we get all of these information here, we run through a process called discretization, which effectively turns this part into a structure. And then we take this structure and run for calculations to solve for displacement. After it calculates displacement, then we get stress, then we get strain. So let's analyze this part. What I've got shown here is an exaggerated deformation scale that shows the behavior of the model. So one thing that we can do with interactions of components is we can animate how this part is going to behave and interact with other assemblies. This tells us a lot of times how a part is actually going to tend to move in operation. Now, with this exaggerated deformation scale, the part doesn't actually physically move that much, so we can modify it and take a look at how much it actually moves by scaling it to a true scale. So now I can see the actual before and after result of this. It's not changing much, but you can see that it does deform. Then, true to real life, if we are trying to run an analysis of this part, we're trying to give our product a safety rating. So I put in 110,000 newtons, and the yield strength of my material is displayed here on this chart. So I have a stress in this chart that shows that I am well above the yield strength of this material. So what we can do is create things like a factor of safety plot to check for safety. And after I get my factor of safety, I can tell that my minimum factor of safety in this part is 0.506. What makes this a valuable bit of information is that now I know that my part is not going to pass a safety check, right? If I put this sort of load on that. So now I need to be able to guarantee some sort of safety rating or load rating for my product. Well, I can come in and I can multiply by 0.506 to get an allowable load that I could put on this to get it to a factor of safety of 1. Then I could divide that by 2 to get a factor of safety of 2. And then I can rerun that analysis. And that tells me that if I wanted a factor of safety of 2, then my allowable load would be 27,830 newtons. Just the ability to be able to do this for your products adds instant value. How much force does it take to make this model break? What are the expected loads on a product. With these answers, you can make a lot of powerful design decisions, and you can guess and test literally as fast as I'm doing this now on the screen and validate your products. Let's take a look at a more complicated example. I have one of my favorite models here, rally car suspension. And I do want to talk a little bit about what it looks like when you go into an assembly. SOLIDWORKS can do parts or assembly modeling with linear static FEA analysis. We just have more parts. We have to define more materials. We have to define more connections, pins, springs, hinges. We have the capability to emulate all of these standard engineering solutions. As the problems scale up in size, we'll create our mesh first, and you'll actually get to see the solver window for a brief instant here. The size of the solution goes up. But even considering the size of the solution going up, I can make engineering decisions about this model just based off of my first iteration. If my yield strength is 620 and my highest stress is 474, that gives me some allowable factor of safety. But what if I wanted to optimize this design? What if I wanted to change the model and try to get some weight out of it? Or I wanted to do a before after, a what if scenario. What happens if I shrink this plate? Or I can answer a simple design question. How thin can I make this part before it's unacceptably thin? So with these studies, you can run them concurrently and you can change dimensions of the part and you can get instantaneous results on different iterations. I can change from a 1.5 to a 2 millimeter to a 3. All I have to do is run this study with its concept with the design study to get different iterations of the model. And then I can validate whether my stress is high or low enough to process this and decide if this is a good or bad engineering decision. So I have 15 scenarios, and to run these 15 is just multiply that runtime that you guys just saw by 15. So this is a great thing to do right before lunch, right? You hit run, you walk away with all of your scenarios running in the background, you come back, and then you can read the results. You can look for stress and displacement and factor of safety, and then, of course, you can analyze trends in the design. So how thin can we make this before we have diminishing returns? Solution 6 tells us about 4 millimeters on that plate. So design history capabilities. How many times can you rebuild and emulate this part and get to an answer? As many times as you want. So as I was mentioning before, this is where innovation occurs. Since these tools are fully embedded inside of SOLIDWORKS, it allows you to do real-time what-if scenarios. You can optimize your designs, and you can reduce the cost of real prototyping because you can check all of this stuff as you design, and it makes for a very powerful tool. Bringing a product to the market successfully involves many departments inside a company. Each department has its own set of responsibilities, deliverables, and challenges. The personas you can see on the slide would be a basic list of people who could be impacted by design validation benefits. Let's review together some of these key challenges for these personas, some critical business issues, and take a look. You might be one of these people. Let's start at the top, management of the company, CEO, or executive level. Typically, the CEO has responsibilities as a communicator, decision maker, leader, and manager. The decision-making role involves high-level decisions about policy and strategy. As a leader, the CEO drives change within the organization. The executives team is driven by the desire to improve the value to the customer and better illustrate it, reduce operation costs to improve profitability, develop corporate sustainability strategies, and position the company as an innovative enterprise. A technical manager's role is to manage and investigate new products and to look over processing and manufacturing equipment. Often, this involves overseeing the organization of the product development team. In his role, he is executing the corporate strategy, such as an innovation in a particular technology or implementing corporate sustainability targets. The technical manager provides technical direction in the execution of product development projects. Often, he or she oversees a number of projects and needs to manage each project's budget and schedule to meet delivery time. This manager also typically keeps close contact with manufacturing managers, and often that key contact when it comes to standardization of softwares inside the company is this person. They're looking for budget and time optimization. It's what they care about. The project managers can have the responsibility of the planning, execution, and closing of any product project. They might also be called design team leader or design team manager. They are managing or leading the design team. So they have to motivate the team members, clarify difficult design issues, and orchestrate everyone's efforts so the product development process is as efficient as possible. They manage the design team, making sure the products designed meet requirements such as quality, reliability, and safety while answering the delivery time constraint. The primary mission of manufacturing managers, also called production managers, is planning the production schedule with budgetary limitations and time constraints. They determine which machines will be used, whether overtime or extra shifts are necessary, and the sequence of production. They also monitor the production run to make sure that it stays on schedule and on budget, and they correct any problem that might arise. Manufacturing managers also monitor energy and material costs, looking to optimize material usage and disposal. And there's no doubt that the contributions of all departments within a company drive the collective success of the organization. But without product sales, there is nothing. If the sales force does not sell the products to a customer, all these efforts are of no use. The marketing team develops a marketing strategy designed to maximize the revenues and profits of the company. With this strategy, they need to position the technology of the company as reliable and innovative in their market. They would also leverage environmental claims for greener products to illustrate the corporate sustainability targets. The sales force will promote the company products to the customers, and so you have to innovate products to delight those customers. Then lastly, quality managers develop, coordinate, and improve the quality policy of the company. One objective is to achieve the corporate quality targets to meet customer needs. Quality is not just related to product quality, but also to the quality of the entire development process, including prototyping. Quality management therefore uses quality assurance and control of processes as well as products to achieve more consistent quality. So all or most of the players care about these issues in the company. These players each have their own objectives and responsibilities and also have common challenges in terms of quality, cost, time optimization, and their group's willingness to innovate. Design simulation tools can impact the efficiency and productivity of the entire team to make a positive impact for the company. Now, let's talk about how. How do you use it? How does it do all of these things? To reduce cost. Simulation helps reducing costs in manufacturing and engineering because the demands to reduce costs never go away in a company. The objective could be to reduce operating costs, manufacturing costs, prototyping costs, or more generally to manage budgets. Either way, sometimes you have a product that just has to change. This means that your company has to find a way to reduce costs while simultaneously working for growth. Integrating simulation inside your design process helps develop a cost reduction strategy that maximizes efficiency without compromising growth potential. Indeed, comparing design scenarios and optimizing your design, either in structural, motion, or flow simulation, helps reduce weight and then material costs, but it's important to know that SOLIDWORks Simulation offers technical insight to improve your product performance and quality through virtual prototyping. Virtual prototyping gives you design, engineering, and manufacturing departments the ability to virtually explore a complete product before it's built. By using virtual prototyping with SOLIDWORks Sim, designers and engineers alike can visualize and simulate the real-world performance of a design in 3D, helping to reduce their reliance on costly physical prototypes. And the same thing applies if companies are outsourcing product testing. If you're going through a third party, right, it's costing you extra money. You can insource that. With an integrated simulation approach, you can keep the control of your product performance in-house quickly and easily. Simulation also helps improving process efficiency. Nowadays, companies are constantly looking for ways to streamline operations and increase efficiency, but without sacrificing the quality of their products delivered to the market. Integrating simulation into the design process helps companies to improve process efficiency, as they can perform in-house performance and quality testing without relying on that third party that we just talked about. Simulation is in a fully embedded step of their product development process and helps to optimize that design. When doing real physical prototyping, companies have to wait to manufacture the prototype itself, test it, and receive the test report before being able to make any tangible technical decisions. This means that the product development process is stopped during this phase. By testing the product behavior while designing for it, designers can see the product behavior while they are designing, and they can adjust, change, and optimize in a timely manner. You can perform in-house static and fatigue testing and detect potential design flaws before you manufacture the product, before you waste time building that machine and then have it fail on you. You can get a lot closer to a real-life actual solution in Sim before you build that first try. Simulation helps improve product effectiveness. Efficient introduction of reliable, compelling products is the lifeblood of product companies. This means that companies have to ensure their product effectiveness for the various physical cases this product might be exposed to in real life. Each and every product has its unique features, which lead us to prove its effectiveness. Over-designing is not an option anymore, as this increases cost. If your product is submitted to important load forces, it makes sense to test its performance using common stress scenarios with SOLIDWORks Simulation. If the same product is submitted to repeated load, you should also include fatigue phenomena, which can lead to performance issues. You can check all of these things, again, quickly and easily with this tool. But don't just take our word for it. Our resource library on tpm.com has many customer spotlights and testimonials highlighting what simulation and TPM's approach to simulation consultation in this product line can do. There are just a few of the many successful companies on this screen that utilize simulation within their development process. ATI, Polymer Center, Wabtec Passenger Transit, all of these companies use simulation effectively to do all of these things. This is where innovation starts. Now, next steps. How do you get started using simulation? 3 steps, pretty easy. Most of you may actually already own a simulation tool because, again, SOLIDWORKS Premium comes with linear static analysis for assemblies. If you don't have that, let's evaluate your use case and get to know your products and process. Granted, not all customers will use simulation the same way. In fact, almost every customer differs in how they will use SOLIDWORKS Simulation. We would actually love an opportunity to speak to anyone on specific simulation questions relative to their products. For training, that last step, our 3-day introduction course will have you going through the basics of FEA and have you using simulation that same week on real-world scenarios. TPM specializes in custom simulation training that is catered to our clients to get them up to speed on these tools in the most cost-effective manner. The true impact of SOLIDWORKS Simulation, in my own words, is what it can change about your design process. The time and money it can save at several points in your engineering process is usually measurable and far above the investment cost of the software. If you're currently evaluating these tools or have an interest in what the impact of this technology could have on your business, please reach out to us after this presentation to speak with one of our consultants. That true impact, in my own words. Now, I'm going to now swap over to Q&A. I do have a couple of questions coming in, so I'm going to address some of those now. If you guys have additional questions about the content that I've just gone over or about the software in general, I'm purposely trying to keep it high level here because there are many of you on the call and many of you create so many different products. You all use this software very differently. Feel free to load up on questions. I'm going to start at the top. I did have a question come in talking about the CFD package in SOLIDWORks. The question was, do you guys have CFD and is it built into SOLIDWORks Simulation? The answer is kind of. So SOLIDWORks Flow Simulation is actually a different product, and it works in the very same way that SOLIDWORks Simulation does. All of our simulation tools do work inside of SOLIDWORks. There's no export or import functionality. So SOLIDWORks Flow Simulation will just have another add-in tab, just like SOLIDWORks Simulation. Next question here. Can you guys do thermal simulations and find temperatures inside of an assembly? Yes, and in a multitude of ways. If you're looking for thermal stress, you're going to be using SOLIDWORks simulation. If you're going to be looking for anything that has high convection, you're actually going to do a mix. You're going to combine results from SOLIDWORks Flow Simulation where you get your convective results, and then you could plug that into SOLIDWORks Simulation to get thermal stress, because that heat and energy has to leave that system, and SOLIDWORks Flow Simulation will measure that more accurately than the SOLIDWORks simulation. So you'll actually combine the uses of those two. Someone's asking, what is the cost of the entry-level simulation package? I can answer cost, but it's going to be depending on what time of year you go to buy. So right now there are promos and deals that you guys can get to get access to the simulation tools, but I would have to get an account rep to kind of quote what's available for you, because it depends. If you already have SOLIDWORks, it might actually be more cost effective for you to add another seat with simulation if you're also growing your simulation user along with your SOLIDWORks user. So it just varies. So it's a little bit harder to answer for your specific case. MSRP is kind of listed in some places on the website. You can probably find that information out if you needed to know more. The next question was, how long does it take to learn this? I would say for the basics, it takes 3 days. That first class is a 3-day class. Depending on the customer, if you're doing a custom course, you could probably knock it down to 2.5 days and then supplement the last half of day with a project. We also commonly do that at TPM. So your mileage may vary. It really depends on what you're trying to simulate. If you're doing simple parts and assemblies, you could definitely learn this in 2.5, 3 days through our 3-day course. That course usually retails at around $1,100. So $1,100 to get trained in this, pretty quick.